Well, hello everyone. Welcome to the first live coding session of the HDSC Internship Spring 2023 cohort, brought to you by Hamaye. My name is Ajula Christian, the Assistant Programs Manager and Data Scientist at Hamaye. I'm joining you live from the city of Port Harcourt, Nigeria, and I'll be your host for today. Once again, thank you all for joining. So basically what we'll be doing in this session, we'll be handling some of the concepts of stage A, which is intro to Python for machine learning. So we'll be dealing on Pandas and Numpy. So, and like we all know, some folks might be conversant with this stage A, that might be simple for you, while for some beginners it might be new. So whichever category you fall into, the session is good for you. All right, without wasting much time, I'll start sharing my screen, then we dive straight into the code. All right, let me share my screen. Okay. So if you can hear me, just drop a message in the chat, and I know you can hear me live and clear. So let me share my screen so we begin. Right, so my screen will come up in a little bit. All right, I believe everyone can see my screen now. Okay. All right, moving on. Like I said, we'll be doing some intro to Numpy and Pandas. And as the session is going, you can, if you have any questions, just drop it in the chat session, chat box. When we're done, I'll reply all. So not to cause any back and forth. People just joined. Thank you very much for coming. All right, Numpy, as we all know, stands for numerical Python. Yeah, that's basic meaning of Numpy. It's the backbone of all kinds of scientific and numerical computing in Python. It's a library for Python programming language that offers comprehensive mathematical functions, random number generators, linear algebra routines, Fourier transform, and more. So since machine learning is all about turning data into numbers and then figuring out patterns, NumPy comes into play. So then why Pandas is an open source library which helps you analyze and manipulate data. So it's fast and powerful, flexible also. Then one of the main uses case you come across in using Pandas is to transform your data in a way which makes it usable. So, okay, let's dive straight into the code. As usual, first of all, you import the library. We'll be starting with NumPy data types and attributes. So I've already written down some codes, so I'll just be explaining as we move on, just to save time. Then I'll explain as we continue. All right, so already imported the NumPy. So what we're dealing with, first of all, I'm just to create some dummy data as dimensional arrays in NumPy. Like we said before, NumPy is a library for random number generation and all. So yeah, I'm generating 3 different random dimensional array using np.array. Produce this. So let me just check the shape. So this is just like the basic, should I say, run through of NumPy. That's from the basic foundation. So it's like matrices and all. So I'm checking the shape of what I created. This A1 was NP array of one-dimensional array. A2 is a two-dimensional array. A3 is a three-dimensional array. So checking the shape, you see it here using dot shape. Checking the dimensions, showing 1 for my A1. Then the data type is showing integer 64. Then the size is 3 and it's showing a numpy.nd array. So this is a n-dimension array. So I just created this using np.array. So as I continue, you understand what I'm trying to do. So checking the shape of A2 is a 2 by 3 shape. That's a two-dimensional array. Then A3 the shape. Mind you, I'm working on my Google Colab. This is not a Jupyter Notebook. This is on Google Colab. So whichever one you like using, Google Colab or Jupyter Notebook, fine. So breaking down the let me run this A3. So this is the A3 I created just now. So let me just give a brief run through of the anatomy of a NumPy array. So like the first one I created, which was A1, which is an array. This is data 1, 2, 3, and array. It's an array and it's a vector. It's a one-dimensional. It has a shape of 1, 3, which is this and this, vertical, horizontal. Then for my A2, it's a two-dimensional array. That's also a matrix array. So it's a 2 by 3, the shape here. You can see my cursor clearly. Then for the three-dimensional array I created, this is just like I'm showing the anatomy of it. It's a 2. This is if green you're seeing. As 0 means the axis, the vertical axis, that's the columns. This time around, not the rows. As it's 1 is the rows. So this is just a brief run through of what I created for the A3. It's a 2 by 3 by 3 array. So this axis here, 2 by 3 by 3 array. So this is just a pictorial view of the dummy data set I created. Then moving on to our next code. So I just want to create more simple arrays to explain. Why I'm doing this is for you to have a brief understanding of the foundation of NumPy with arrays. So when you're working with read data sets, you understand better how to manipulate your data and others. So creating an array of ones using np.ones and 4 by 2 array. So this is 4 by 2 array. Then creating an array of zeros using the np.zeros. I want to create a 5 by 3 by 3 array. So this is the 5, 1, 2, 3, 4, 5 by 3, 1, 2, 3 by 3, 1, 2, 3. So this is just what this pictorial view was explaining previously. So even as I'm explaining, you still don't understand, just drop your question in the chat box. I will explain when I'm done. All right, then create array using a code called np.random.randint, that's rand integer of 10 numbers, that's from 0 to 9 with size 5 by 3 array. So you can also use this code. That's what this code is explaining here. So let me just run the code, you see it. So this is a random array created using random integers from 0 to 9. That's what this code here is doing, size 5 by 3. So this is a 5 by 3 array. So this is just some codes on how to create a dummy data set. And I'm just doing this so as to explain, so you get a good understanding of how you wrangle your data with NumPy. So just try and follow along. When we get to work on the real data, you understand better. So also, since, for example, I created, if you notice this code here, I created a random numbers, an array of random numbers. If I run this code again, so create another different set of random numbers. So if you notice it's 220, I create a different one, it will be 025. So in order for you to have, if you want to create a data, you're working with your data set, not to have different random numbers. There's something you call to set it to produce the same set of numbers or the same set of data. You can do a setting called random seeds. So you can do that by doing np.random.seed. So in your seeds, you can start to set it to 0, seed to 2, seed to 42, so whichever one you prefer. You can also check the documentation to see which one is generally used. Like for me, I prefer setting my seed to seed 42, but for me, I'm using seed 0. So this np.random.seed, it ensures there's still randomness, but it just makes the randomness repeatable. So you have the same set of numbers or data you created before. So that's why it's called pseudo random numbers. So I was doing that, creating my the previous data I did before with the same code. So if I run it more than once, it will produce the same set of numbers. That's the essence of np.random.seed, setting random seed. Okay, now after creating this dummy data, this array, I want to put it in a data frame. So in Pandas, there's something called pd.dataframe. This is what can create a data frame for you. So I will import my Pandas as pd. And mind you, you can import Pandas as anything as you like. I can write import Pandas as my name, Christian. To still work, I'll write Christian.dataframe. So you can import whatever you're importing as anything you prefer, but this is just the standard way of doing it. Import Pandas as pd. So putting this in a data frame. So I have it in a data frame. So this is just how you work with Pandas and also with Numpy. So I just created these random numbers array and put it in a data frame using pd.dataframe. Okay, so now I want to view my arrays and matrices, because we know that array shapes are always listed in the formats row, column, then the different array numbers. So checking our previous array I created before to be sure. So let's manipulate this data a little bit. So what this code does here, my a1.0, this is indexing. I want to view arrays and matrices using indexing. So in Python, if I call this called a1.0, the zeroth index in this my a1 here. And if you remember in Python, the way you calculate your index, it starts with 0, 0, 1, 2 to whatever number. So if I want to call the zeroth index here, it will be this 1, or this is my a1. So calling it, let's say a1.0 indexing 1. The zeroth index of my a2 should be this 1, 2, and this. So mind you, working with this in this my two-dimensional array, the zeroth index was this rows. That's why if you see it here, 0 to 0th index, it gave me this. Then for my a3, what do you think it will come at? For my a3, it will pick this first one. Since the shape is 3 by 3 by 3. So it will pick this first one here as 3 by 2 shape. So it's 0th index, which is this first one is 0, second one is 1. So this is for arrays and matrices, mind you. So that's how you get to manipulate data and select a particular point in your data. So this is just indexing in Python. There's advanced indexing, then when you get there. So this I want to get the second row, index 1 of A2. A2 and 1, that's my second row. Then to get the first two values of the first two rows of both arrays. That's, for example, if my A3 data, I want to get the first two values of the first two rows of both arrays. So I come and write this code here. This is indexing. So this means, what this means is from the first index to, that's the first two values. So this means from 0 to 1, excluding 2. That's what this code is doing here. So Let me just run it. You see the value that you bring up. So if you go back to the A3, this is our A3 here. So the first two index, which is that 1 and 2, 1, 2, 4, 5 of the first two rows. So this is 0, 1, 10, 11, 13, 14 of the first two rows. Row 1, row 2, row 1, row 2. So sometimes it might be confusing, but if you just try and pay good attention to it, you get a hang of it. All right, so moving on, I want to create another random to explain what I just did with indexing. Let me create another different random data set. It will be a 2 by 3 by 4 by 5 shape. So this is, you look at my data very well. This is 2, this stuff is 2 here, this and this, by 3, which is 1, 2, 3, each of them, by 4, which is 1, 2, 3, 4, by 5, which is 1, 2, 3, 4, 5 array. So this is just the shape of this dummy data set I created using Numpy array. So checking the shape, you can do that by dot shape. It will give you the shape of your array or the shape of your data set. If you're working with a large data set, that's a real life data set. That's how you get to do that. Okay, now want to work with aggregation. That's how you mesh two different data. And also, let me just start with the basics. So let's go back to our A1 we created before to see. So these are A1 data, our array. So np.sum of A1, we want to check the sum of this whole data in this array. Do np.sum. Mind you, to understand how to do most of these things, the documentations, you can go back to the documentation, it's there. You see the different things. That's the best way to understand. Go back to the documentations and understand what you're trying to do, basically. So let's check our A2, manipulate the data. To check the main of this A2, there's something that you can do called the np.main, and you call the data A2 to find the mean, which is 3.6.33. Then for the maximum value, you can do np.max, which is 6.5 here. Then for the minimum value should be 1. You can do it by calling np.min. That will be A2. Then to find the standard deviation, you can do np.std. Find the standard deviation. Then to check the shape, of course, as usual, np.shape. Then to add both, sometimes you can't add two different arrays if they are not of the same shape. So if I run this code now, it might throw an error. You see, it throws an error and says operands could not be broadcast together with shapes. So there are two different shapes. You can't add or aggregate two different data that are not of the same shape. You run into errors. So to do that, you check the shape of A3 because I wanted to add A2 and A3. So I now have to reshape my A2 to the shape of A3. This A3 is a 3-dimensional array. I can reshape my A2 to a 3-dimensional array also. So A2.reshape, there's a code called .reshape. It will reshape it for me. Then adding my new data with the A3, see, I could add it. So I could do some aggregation, that's addition or dot product and all. So mind you need to understand the shape of the data you're working with. So there are different ways you can reshape it. And you should also check the error message it throws for you. It will show, probably this one is a value error. So operands could not be broadcast together with shapes. So from there, you can reduce or debug your code. And also in Google Colab, there's an option for search Stack Overflow, or you can use GPT, whichever. So there's another function called transpose. It switches the axis. From here, it will transpose it for you, A2.transpose. These are, if you did mathematics in school, you should understand this when working with the matrix and vectors. So transpose, the transpose our A2 data, then checking the shape of our transpose data, 3 by 2 before it was a 2 by 3. All right, moving on to the next stuff with working with array using Numpy. I want to go to the dot product. So I want to create two dummy data. This is dot product matrices, creating mat1 mp.random.randit from 0 to 9, size 5, 3. This is the shape. So creating it with two different data sets, mat1, mat2. Mat1. If you don't understand so far, just leave your message in chat box. I'll give you a reply when we're done. So checking the shape of both data created, 5 by 3, 5 by 3. So I want to do a dot product. That's, you know what dot means? That's you're multiplying both. Let's see if this will work since they have the same shape. They did not, because this time around they are the same shapes of 5 by 3, but they are not aligned in terms of dimension. That's another thing you need to understand. When working with dot products, you want to add or multiply both matrices together. So just I'm going back to foundational mathematics. So to do that, you see it says they are not aligned. Dimension 1 is not equals to dimension 5. This is dimension 1, dimension 0. So to do that, I have to transpose my text data, which is mat1, transpose it. If you notice, it was previously a 5 by 3, but the dimensions is different. But now I transposed it. So this 5 here, this first column became the first row, which is this. Then checking both shapes. Then doing my dot product. So you see, I could do a simple calculation of both matrices. All right, so okay, moving on. Like I said, if you have any questions, just drop it in the chat box. Saw somebody raising hand just now. I'll get to you. So okay, now let's work with create a real kind of like data set we can all understand more instead of creating random numbers. So I want to create a sales data. I call this sales amount. So putting a random numbers into this my variable called sales amount using mp random.c to mp.random.roundit. So this is my sales amount. That's like particular column. Then creating a weekly sales. So I want to create a sales data. First of all, I created the sales amount using mp.random. Then I want to create what we call the weekly sales. After creating the weekly sales, I put it in a data frame. So like I recalled before with Pandas, you can create a data frame using pd.dataframe. And you have to understand it works like dictionary, key value pairs. So if you check the documentation of the data frame, Pandas data frame, okay, with Collab, we'll explain it to you. So if you see what this Collab is showing now, that the first part you can put the data, and the second one can be the index or the columns. This is how you create a data frame. The documentation of the data frame, you pass in the data, and you pass in the index and the columns. So just like key value pairs, like in dictionary. So for the sales amount, I'm using this sales amount data. Then the index, I'm adding the indexing Monday, Tuesday, Wednesday, Thursday, Friday. Then the columns, I'm creating the columns called what was sold, almond butter, peanut butter, cashew butter. That's what this code is doing. So if you notice, we just created a data set and passed it into a data frame. And I can decide to save this particular data. So if you notice, this random MP array is what I just created here. I passed the indices. Normally, this is supposed to be index 0, 1, 2, 3, 4. So I placed it with Monday, Tuesday to Friday. Then the columns of each of them to this name I created here. Okay, so I want to create the price array. So I'm creating my data sets. After creating the sales and what we sold, I want to create the prices column from a different random array of numbers. Then creating the prices of each column we created before. So I want to add it into the data frame. So that's what this code is doing here. The prices, which is this, I have to reshape it because it's like n dimension of 0. So I want to change to a dimensional of 1, so it to be straight. So of course, I'm using the prices as the data. I'm reshaping it to 1 by 3. The index will be price and the columns will be this. So let me just run this particular code here. Okay, I'm too fast. Okay, I'll try and slow down. I didn't know I was too fast. Okay. Let me slow down a bit. So let me just go back to when I was creating this data. I believe you understand it from when I was doing my addition, dot product and all. Let me go back to when I was creating a data set. So like I said, I created a random numbers called says amount in an array using np.random.randint. This is in the Numpy and Pandas documentation. So this is in the documentation. You can go back and get a good understanding of what I'm doing here. So that will help you more. So I'm not creating this stuff. It's not rocket science. It's already in the documentation. So, and of course, you get this recording afterwards. It will be on our YouTube. It's streaming live on our YouTube channel. So you can go back and watch the video. So from here, I just created with this data I created, I just added the column to it. Call this Mondays to Friday, call this the name of my data. Then here I created prices using np.array. Then here I created the butter prices row. That's what I just did. So now I want to add everything that I did together called total sales. So I'm using a dot product. So if you're working with three data sets, you might not go through this process, but what I'm doing is so that you have a base understanding of how Numpy works. So this can help you when you're working with large data sets. You know how to manipulate, how to wrangle, how to add data to your data, how to remove a particular column and what's not. So that's the essence of this. So if I run this code, do you think this will work? Prices dot sales amount based on their different arrays as different dimensions, they might not work. So let's run the code. It will throw an error. It's taking time to load. Network. Let's wait for it to pick up. So it's didn't run, it throws an error because they are different shapes, they are not aligned of different dimensions. So now what you do is to transpose either of your data. So here I decided to transpose my sales amount data, which is this guy. No, sorry, not that. This guy. So transposing that using sales amount dot t, that's transpose, adding the prices column together, I create my total sales, which is this. Then checking their shape, you see 1 by 3, 5 by 3, so dimensionals should work. Then transposing my weekly sales shape. Oh, sorry, checking the shape and transposing it from a 5 by 3 to 3 by 5 shape. This is what this is doing. Transpose is just to transpose the shape. Just like what we did in mathematics in school in metrics or vectors. So creating my daily sales, mind you, I'm just creating dummy data. You might not decide when you're working, you might not decide to create your own data set. So, but it will be beneficial to add data to particular data you have. If when you go deeper into machine learning, if what you're trying to solve, your data is not complete, you can add foreign data to it. So these are ways for you to understand better. So create my daily sales column. The butter prices I'm adding to this weekly sales, and I'm going to transpose it. So you see the shape. That's what this code is doing, 1 by 5. Then check the weekly sales shape, 5x3. Then checking the weekly sales data. This is the data we have here. So now I want to add another column for the prices in this my data set. Since we just have numbers, you might not know what is this dollars or is this a total of them, are they numbers or what is it working with? So I want to add daily sales and create a new column called total here. So to do this, I can decide to make it daily sales, but mind you, your daily sales shape is different from this weekly sales data set. So if I run that, it will not work because they have different shapes. You see, through an error said, cannot set data frame with multiple columns to the single column. So to do that, I have to transpose my daily sales column, which is this. Where's the daily sales, guys? Yeah, which is this. So transposing that, we now see we've added a total column. So this is just a total of this and this. And the way we did it was we added everything here using dot products. That's a weekly sales. Do you get it from here? So this is just ways of creating data, wrangling your data, working with this. And if you notice, I just created this from np.array, created a random array of numbers, created this column using pd.data frame, which is key value pairs like a dictionary, created this total column. There are other ways you can still do this that will be easier for you. When we move forward into Pandas, you understand better. So this is just like a crude way of doing it. There are other ways you can still do it, but it's not bad to have this particular understanding of Numpy arrays. So moving on to Pandas, basically, Pandas has two main data types, which is the series and the data frame, which is the series and the data frame. So don't worry, I'll get to your question when I'm done. So moving on, okay, someone is asking how did this sum up to 240? Mind you, this total is daily sales here. Let's go back to this code, dragging data. The daily sales is the butter prices dot the weekly sales, which is this. Butter prices is this. If you go back to the code, these are butter prices of each of them. It's like a different, this is not the same as what you call it, this. So this is different. This is this butter prices. I created butter prices separately. Let me go back to code, you understand better, which is the 10, 8, 12. This is my butter prices. So that's what it did there, dot the weekly sales. I just created that, I added that column. So it does not represent what you're saying if it was a total of this. Do you get it now? If you get it, just drop it in the chat. It's a dot product, not add product. So moving on, in Pandas data types, we have the series, which is a one-dimensional column, and data frame, which is a two-dimensional table of data with rows and columns. So you can create series using pd.series. You can create data frame using pd.data frame like we did before and pass it on to the Python dictionary. So let me just do that now. As usual, I'm creating a dummy data. So I'm importing my pandas. I imported it before, but let me just import it. I'm creating a column, a series data called cars. And in the series, I want to put the names of the cars, BMW, Toyota, Honda. So this is my cars series data, which is a one-dimensional column of data. It's a column of data. You check data type object. This is a PD series data. So creating another series of colors. If you remember what we did before, we're in array, we're not in series. So now with PD, we can create series. we check the data type is different from the previous one. So creating a columns data that's the type of the colors, blue, red, white, pd.series. In Pandas, I told you before, I have two data types, pd.series and pd.data frame. That's how you can create your data frame, create your series for both. If you get somebody asks if you have the link to this collab notebook, no, I'm not sure. Don't give any promises now, but this video is always available on YouTube. You can always go back and check. So not necessary that you have this link to this notebook. So moving on, putting this both series into a data frame. Let me go back to what I explained before. You can create a data frame using pd.dataframe and pass it to a Python dictionary. So passing this data created into my Python dictionary called car data. So it's with pd.dataframe. And with data frame, you can do what we call key value pairs. Key value pairs. My car type is the key. The values is this cars series. Then my color is the key. Then the values is this colors series here that I created, this variable. We have the blue, red, white. Do you understand? So let's run that. All right. If you're just joining and you are kind of like lost, you can always go back to this video on YouTube to get an understanding. So let's view our car data we created. Okay, to view the data, just show you here. So this is like a data frame of this series we created here. It is now in a data frame data type. So now, this was how I just created dummy data with PD. So since I've been working with dummy data that I've created, so now I'm going to work with a real life data set that I already have on my Google Drive because I'm working on my collab. So importing this, I have a dataset called car.sys dataset in CSV format. So I'm just going to import this. You know how to read your data, pd.read CSV, if it's a CSV data. So I'm going to call it car.sys. So let's work on a read data. So this is my read dataset I have that I imported. So this is just what I have in data frame. Just let me run that code to check the description of it. But basically, before I do that, let me just explain the anatomy of a Pandas data frame or data set using this picture. For those asking for this data set, yeah, it's been provided on the Slack channel. I'll post this data set in Slack channel so you can go and do your practice. But for this collab notebook, we're not making as we move on. Try and listen and you get a hang of it. But the data set will be provided. Explain. So explaining this anatomy of a Pandas data frame so you understand when you're working with it. So this stuff here marked green, these are the data. Then these are the column. The column is always in Python data frame is as this one. For example, if you are moving this mid column, you will not call as this equals to 1. So for your as this in column is called as this 1. For the row column, sorry, that starts at 0 by default in Python, start from 0, next one 0, then 1, 2, 3, 4, 5. Thomasine, you can't hear me. If you can hear me, just drop it in chat. Okay. Can everyone hear me clearly now? Okay, good. Okay, sorry about that. I think I had a little bit of network glitch. So let's go back to the code. Share my screen once more. So can everyone hear me clearly now? And you can also see my screen. Okay, lovely. Okay, sorry about that. So moving on, as I was explaining, the rows data is always referred to as 0. That's when you're manipulating your data. The columns data is always referred to as x1. Then these data inside are your data in the data frame, in this particular data frame. So moving on, we'll be wrangling this particular data sets. So checking the data types of each column in our data. This is object, integer. And if you remember, if you have an understanding of data types in Python, we have objects, we have integers, we have Boolean, we have so many others. So you can go back to data types in Python, you understand? So for this, in a particular data frame here, we have the object data and the integer. So this object data is what we call the categorical data, because they are not numbers, they are words. This Toyota, this is white. So this make and color column are categorical column. So for the integer here, which is numerical, integer 64, it is this odometer column because it's represented in numbers. Then this price column is set to as objects when this data set was created. But based on the fact that you're seeing numbers, it doesn't necessarily mean that it's categorical data. So you can have to convert it when working with it. So that's how you understand your data. You don't just assume. To know the data types in your data frame, you can just run what we call .d types. Call your variable, your data frame, then you put your d types. Give you a good understanding. There's another function you can use called the .describe. It will describe the major things in your data set. So it will tell you the count, the mean value, the standard deviation, the minimum, the maximum, your 25th to 75th quartile range. So for these are data sets, the mean value is 78,000. The mean value of the numerical columns, it will not tell me value for categorical columns. So it will only show you this describe will only show you details of your numerical data in the column. That's what it's going to do. So you can look for mean of categorical data. So that's when you do feature engineering and processing your data when you get to machine learning. All right, so I believe everyone can hear me clearly. Okay, good. So moving on, checking the info. To check your info of your data frame, you can use cars. You can use .info. .info will give you a better view of your data. So yeah, it's showing that it's a Pandas data frame. It's the range of 0 to 9. That's your index here from 0 to 9. If this data frame has an index of like 100,000, vary from 0 to 99,999. So that's what this is showing here. Then to show you the amount of the columns you have in your data. If, for example, your data is a very large data, then when you click on view, it might be more than the your view in this UI. So to get a brief understanding of your data sets, you can use the .info to give you everything of your data. That's when you are working with large data sets. So for here, it shows data, the non counts, data types integer 2, object are 3, the memory usage. So this data frame is using 528.0 plus bytes on my memory. So just like we did before, this describe will show you major statistics of your data. But you can also use if you want to check for the mean, you can use .mean. If you want to check for the columns, you can use .columns to tell you all columns in your data set. For example, if your columns are many, you have like 30 or 50 columns and you can't view them, you can just do .columns to tell you all the columns in your data sets. So this is what is helpful in Python. This is Pandas, sorry. Now, working with, I want to do more wrangling and selecting the data. So since I have these car columns, yeah, I want to save it to a list. Okay, so saving it to a list, I'll call the variable car columns. Since our columns are make to price, I want to save this particular column into a list. Save it to a variable called car columns. So calling it, I can try to work on it better and say, okay, I want to select the first column. What's it called? Make, which is this indexing also. Then checking the index of my data sets, it starts at 0, it stops at 10. So for example, you want to see, you're working with a large data set, you can also use this code called .index. So if you see, it gave me, it says it's the range of index from 0 to 10 with step 1. So it is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, step 1. So this will show you more info of your data set. So, and also there's one keyword you can use called the len. Can tell you the length of your data frame. So the length is also 10, which is within this range also. So these are a way of selecting and understanding your data sets and wrangling your data. So I want to go on to viewing and selecting your data. Mind you, I'm working with this data set I imported from my drive. It will be shared later on the Slack group. So you can go and later and play on with it. All right, so viewing and selecting data, I want to check the first 5 rows of my cars data. That's, for example, you're working with a large data set. If you just call the data frame, it's defaultly Python will truncate it for you. It might show you the first 3 and the last 4, whichever way it is. But there's something you can use called .head to always show you the first 5 rows defaultly, or first 10, whichever ones it shows. Then for you to check probably the first 2 rows, excuse me. So for you to check the first 2 rows, you can say classes.head to represent 2 inside here. So I want to check the first 6 rows here in this code. I can say classes.head, put 6 here to show me the first 6 data in my data frame. So these are just basic stuffs when running your data. To check the last part of your data, if you're working with large data sets, you can use what we call .stay to show you the last 5 rows. And inside that .stay, you can look for the last 3 rows, the last 10 rows, the last 2 rows, whatever way you want to play with it. So this is it, showing from 5 to 9. Now working with what we call .lock and .ilock in Pandas. .lock takes an integer as input and it chooses from your series or data frame whichever index matches this number. So I want to select the row at index 3, which is from 0, 1, 2, 3. This particular row I can call classes.location 3. Classes.location 3. I hope everyone can hear me clearly. Just drop it in the chat. So I continue. Okay, you can hear me clearly. Good. All right, if I run this code, it will produce this row and to bring it out in a series format. So I just wanted to print out this row 3 here, everything here using .lock. And there's another one called .ilock. So I'll get to that. I'll explain the difference between those two, .lock and .ilock. So this just printed that the series data of that particular row in my data set. Then y.alloc, it does a similar thing but works with exact position. That's what alloc does. It does the same thing, but it works with exact position. For example, I just want to find this third row and particular this third row and a particular number in this column of these rows. I can just select it using .alloc. But first of all, let me just check alloc row 3, pretending that, and you can also slice with lock and alloc, what we call slicing in data. You can go back and try and understand the meaning of slicing and indexing in Pandas and Numpy data frame. So I just want to get all rows up to and including index 0. So I want to slice my data. I want to select this row from the first one to 3. I can do that using lock. So classes.lock. What this means here is from the first to the third, including my index 3. This is what this lock does. But if you don't use lock and you want to use classes and put this brackets from 0 to 3, it will only produce from this to this 2, but it won't work with data frame. So with lock, you can use it to slice your data frame. That's the benefit with lock and ilock. Then moving on, you might have a question on when should you use lock or ilock. So you use lock when you are referring to indexes. You use ilock when you are referring to positions in the data frame. That's when index is out of number. And also, you can also just call the column name. That's when you want to get, for example, I want to get this odometer column. I can just say the name of my data frame, cast is, and put brackets, doors or odometer to print out everything for me. So that's what that does. So let's try that with the color. And it will bring it out in a series data frame. So checking this color, all the color in my cars data frame, I can just call the data frame and call the name of my column and bring out just that particular data in my data set. Also, you can work with Boolean. If you remember, we're working with data types, integers, objects, Boolean, which is true or false, or if this is that, it's not that. Well, let me just get into the code you understand. So Boolean indexing works with column selection too. So using it to select the rows which fulfill the condition in the brackets. So with this particular code, I want to select cars with over 100,000 on their odometer. That's this odometer column. I want to select the data that has odometer of 100,000 and above. So if we run this 87 will not come out, 32 will not come out. Only the data in this odometer column that has 100,000 and above. So running this code, we'll call the data sets in the bracket to call the classes and call the particular column we are referring to. This is slicing, and using Boolean function if it's greater than 100,000, print it out. This will work with the full data frame to print out the details of odometer that is over 100,000 and above, and to print out the full details of your data frame. So for example, you have a data frame that says it's like patient data in a hospital that has the full data. Patients are diabetic or has malaria or has this. So you can say, okay, the type of disease or sickness they have, I want to search for only patients with malaria or diabetes. So you can go to that column and select patients with, in the disease column, patients with malaria, to bring out all the details in that data set of those that are with malaria. So you can use Boolean to do. So with this, I just said with in the odometer numbers that are greater than 100, I can say that are greater than or equals to 100. I can say that are less than 100 to provide data. Okay, moving on, I want to select the make of the cars that are of Toyota. Mind you, in our data frame, we have, let's go back, we have different make. We have Toyota, Honda, BMW, Nissan. So in this my car data frame, I want to select the data that the cars make are just Toyota. So give me the full details of cars that are just Toyota. So I can still use this Boolean format called selecting the make column that the data are the same as Toyota. Then you print it out. And you see it to give you the details of the make column that are only Toyota. That's how you wrangle it. Okay, moving on, there's also something called the cross tab in Pandas. I won't be giving serious explanation on this. You can go and check Pandas data frame. Pandas documentation. You know what the cross tab does, but cross tab is a great way to view two different columns together and compare them. That's the essence of cross tab. So I want to compare my make column with the number of doors in a particular data set. So what I'll do is pd.cross tab, pd.cross tab, classes, which is the make, and classes, which are the doors. So I want to combine these two data sets and compare them. So I'll use the pd.cross tab. You might see this in quiz or not, but so I just compared the doors column and the make column, and it shows me each of their data. So comparing them, which particular in the data frame, in the doors data set, column in my data sets, which how many cars has 3 doors? So for BMW 000 in Toyota make they had 1. For BMW cars that had 4 doors, they don't have the cars in the data frame. So Honda has 3 cars that has 4 doors. Then for BMW cars that have 5 doors. So these are ways you can compare and your two data together using cross tab. That's another wonderful way to do that. Then if you want to compare more columns in the context of another column, you can use group by dot group by. So if I want to group by the make column and find the mean of the other columns, I can use my classes data dot group by. I want to group by the make column, the make, which is this BMW, Honda, Nissan, Toyota, whatnot, and check the mean of the other columns. Mind you, excuse me, this will only work for numerical data type, not categorical, which is, you should know the difference between categorical and numerical. So this was this code just the brought out the mean, comparing both of them. So that group by. These are ways of manipulating your data. I hope I'm not too bad. So if you have any question, drop it in the chat as usual. Then moving on to manipulate this data, I want to lower the make column. That's since they are all capital letters or some are capital letters, I want to make the data in this my data frame to like lower letters. So I can use what we call dot string dot lower the make is to change it to lower caps instead of high caps. Waiting on my network. I'm on collab, not on my local Jupyter notebook. So let's wait for that. It's not supposed to take this much time. But Yeah, sorry about that. I think I also went off, having some network lags. Well, okay, let me continue sharing my screen back to where we stopped. Okay, loading this particular code. I believe you can all see my screen now. If you can, just let me know. Just have a little lag. Okay, wonderful. It's working. So I just lowered my data sets, the make column in data to all lower numbers. This is what this code is doing. Then if I want to make it to also lower, I can use this particular code and set it in a particular column. Okay, so this will just bring out the values. It won't add it to your data set. So if I want to add this particular data to my data set, I can represent this in a variable. So this is how I can do it. I can take my car says make column. I want to lower the strings. That's everything should be in lowercase letters. So when I do that, I run that, it will reflect in my data set. Notice this. Before, if I didn't run this code, after I did this and I run my car sales data, it should be showing all uppercase. So, but this is how you can represent a particular column and define it to something. So this is what this code is doing. Then also to check for your data, if you have missing data, there's something called isNo or isNa, meaning if a particular data is missing in your data set. So I can say car says dot isNo dot sum. So you tell me all the particular column in data set and to return if there are any missing data or not. So for this data set we're using, there's no missing data. There's no missing data. So for this particular data set I was using, like I said, there's no missing data. So, but I also have another data set that I created previously that has missing data. So if you don't understand how I got to this point, you can drop your questions in the chat, and I hope I'm not too fast. If I am, just let me know. Put it in the chat. All right, moving on, loading this particular data set I have. If you notice, there's none, so meaning there's missing data. So I just want to use it as an example of how you work with missing data to check if you have missing data or not. So now checking is now to see if our data set has missing data. So in each column, make column will have one missing data, but the odometer column will have 4 missing data. So I want to talk about how we handle missing data. So since our odometer column, I'm working with odometer column for now, I want to fill the odometer column with the mean of the data. And mind you, there are different ways of handling missing data in your data sets. For the numerical data, you can handle it with mean or mode, or something we call forward field or backward field. Then for the categorical data, there are ways by which you handle the missing data. So I don't think I'll cover that in this particular coding session. It might be in the next. So just follow along. So for my odometer column, which is this guy, I want to feed the missing data with the mean of this total data in this column. So wherever you have missing, to replace it to the mean value. That's what this is doing. I'm calling the cars data dot fill now. Fill now means to fill missing data. So that's what Colab is showing now. The explanation of your cleaner function. So, okay, filling into the main and setting in place false. In place false is set by default in the code. So you can set in place true or not. So what that means is that it will store in your data set. That's the difference between the false and the true. So if we check our car's data set again, you will notice that based on this thing is set as false, it did not replace it. That in place, it don't place it. What we just filled, it didn't place it in our data frame. So to enable what we did to be placed in our data set, you change this in place into true. In place true. So it will put it in place in your data set. So let's run this code again, since in place true. Then you run a particular data set. And voila, it has replaced the missing data with the main of this particular row. Sorry, this particular column, the main data. So that's how you place it. So we can place it with me. And mind you, I'm working with the numerical columns, not the categorical. So there are ways by which you fill the categorical column. So let's check if there's any missing data again. So if you notice, the odometer column is showing 0. There's no missing data anymore. So moving on, you can also, the other ways to handle missing data, you can drop the missing data. That is if it's not too much in relative to the amount of data you have. Say for example, in your data set, you have 20,000 entries and the missing data are just 1,000. So, or let's say 500. So you can decide to drop. So you can decide to drop those particular missing data. It won't necessarily affect your data. So, but when the missing data is like almost the same as total of your, for example, you have 20,000, missing data is like 12,000 data. That's when you now have to handle those missing data. Don't drop it. You have to fill it using different methods. So moving on, I'll get back to your question. Let me just move on and explain something. So I want to fill the drop the missing data in my whole data set. I can call this whole data and call .drop now. It will remove all the missing data in my entire data set. This is what this drop now does. If I want to drop just the missing data in a particular column, I can, for example, this color column, I can say car missing brackets color column .drop now. It will only drop an in place true. It will only drop that of the color column. But since I call the entire data frame to drop everything, since based on the missing data is very small and relative to my entire data set. So running this code, checking for the missing data, and voila, there are no missing data anymore. So for example, if instead of removing or filling the data, you want to create a particular data, add it to your data set. For example, since we had like 5 columns, I want to add an extra column to my data. There are ways you can do this by calling the column name. For example, I want to create a column called engine size. So I can create a column from Python. For my column, the series called engine size, that's the variable. I want to add this. Based on, I'm working with this relatively small data. We just 10 rows. So I just created 10 random numbers called engine sizes. So to add it to my car says data frame, I can just say, call my data frame, call the name of the column I want to create, then equate it to my value, which is this engine sizes value here created. Then let's see if it will be added or not. And if you notice, I have this particular column called engine size column added to it from the series, added to the data frame. If you remember before when we were working with just np dot and array by adding it together. Now this is an easier way by just calling the name of the column and presenting it to a particular value you had before, calling engine sizes column. Then As for creation, I can also create a new column setting that's setting all values to one standard value. For example, I want to create a new column called number of wheels, just like I did ng size. If you notice in ng size, I created a list of 10 different numbers. But for this, I want to create number of ways. I can just equate it to just a single number. It will repeat everything as 4, 4, 4, 4, 4, 4, 4, 4 across each row. So let's run this code. And voila, number of ways that's added to it, 4, 4, 4, 4, 4. I don't understand your questions on YouTube. I'll get to your questions when we're done. Okay, instead of adding, you can also remove a particular column using .drop and call the column name and represent the axis. Are you removing a row, which is axis 0? Are you removing a column, which is axis 1? Always represent it. So if I want to remove this engine size column, I can call my data frame that I want to remove from, which is the classes, and I say classes.drop, open brackets, engine size column axis 1. Axis 1 will tell the program that I'm removing the column, not the row. So if it is axis 0, I want to remove this under column, which is this is that call as 0, and remove that particular row. So this is what this axis 1 is doing. But remember, axis 1 is the column, axis 0 is the row. So running that, notice we've removed the engine size column. So with that, we've come to the end of the whole wrangling, manipulating of the data, creating data using Numpy and Pandas. So if you came in late, you didn't understand everything I've been saying, you can always go back to YouTube. This video will be live on YouTube using the same link. And just go on Harmony HQ, see it on YouTube. It's always there for you to go back and play with it. Even if you're not using this particular data set I have, you can have other data sets. That's if this data set will not be shared or not. And also if this notebook will not be shared. So you can go back to the video and check on these things, and also go back to the documentation of Pandas and Numpy. Just play around with it using a particular different data set. It doesn't necessarily mean you have to use this data set. Do you understand? So if you have another data set, you can just play around with it. So I'm saying this because if this data set and this notebook won't be shared, so you can go back to the video and play around with it. So if you have any questions, just drop it in the chat. Let me see if there are some few questions already. So let me stop sharing my screen for now. If there are any questions, just drop it in the chat. Okay. Okay, someone's asking, there's no attendance for this session. This is a coding session, not part of the compulsory webinar sessions. But it's essential that you attend these sessions. So for these coding sessions, there are no attendance for it. So to clarify on that. Like I said, if you just joined like 5 or 10 minutes ago, you can always go back to YouTube. You get the video there. So any question? Okay, someone is asking a question. How accurate is each filling as compared to mean? Okay, if you're working with filling your data, that's numerical data, personally, I prefer mean. You can also fill it with the mode, but okay, I'll put it back to you that you can go back and do research and see which one is better. But me, I prefer mean, using the mean method to fill my data. And there's another thing called the feed forward and feed backward. Feed forward and feed backward method. What that means is that any part that is a missing data, it will fill it. For feed forward, it will fill that particular missing row with the previous data that wasn't missing. Then the method called the fill backward, it will fill it with a particular value of the predecessing value. I don't know if you understand. So for example, in a row or in a column, the first three, the second one is missing. If you're using a backward field, it will fill it with the third value. If you're using a forward field, it will fill it with the third value. That's just it. Like I said previously, the video is in our announcement channel. Sorry, is in our YouTube channel. You see this live coding session, Spring 2021. And it was already shared on Slack. Both links work, but the Zoom is like a recurring link for several coding sessions. But the YouTube link will lead you directly to this particular session. Another question, 12 p.m. GMT plus 1 is 12 p.m. Lagos time. This question for Formula 12 p.m. GMT plus 1 also means you can, why I'll give this time zones, because there are different people joining from different parts of the world. So before you start assuming, always browse on it, which your particular location, what does this mean? But the coding session will always happen in GMT plus 1. And most times it will happen 12 p.m. If there's a change, it will always be announced on the Slack channel and also on the AMOE platform channel. So always log on every day to see what information will be passed on the announcement channel. So, okay, there's another question from Olariwaju. What will happen if a missing value isn't fed? Is it compulsory with the code run? If you have a missing data in your data set and you want to do predictive analysis when you're running a machine learning code, it won't run, it will run into errors and stuff. It will not work if the data is incomplete. So that's why we call you need to handle your missing data. When you're doing machine learning predictive analysis, you have to handle your data, do core feature engineering. We'll get to that in subsequent stages. Handle your missing data, make sure everything is working, and also convert the categorical data into numerical data that the model would understand. Because if you pass categorical data into your model, it's not wrong. So these are for subsequent stages. You will see it when we do that in the coding sessions. Okay, there's another question. Can there be a session on using Git because we're having issues? Sorry, those are the prerequisite courses. You can always do your own research. Go on Google and several places you see and get to understand how you work with Git. So that will be your personal research. There won't be any session for that. So any other question? We have time for one more question. We have time for one more question. Any other question? All right. Olaranju, you have to handle missing data, fill all your missing data. That's how it works. You have to handle missing data. All right. In the absence of no further question, I hope you enjoyed this particular session. If you have any doubts, okay, good. If you're having any doubts or the part you don't understand, like I said, Google is your friend. There are lots of resources online, the documentations and all. Don't just rely on this session or the resources you have on the platform. You can do your particular research. And like I said, if this notebook and this data set won't be shared, you can download a separate data set and play around with it, with what you just learned. Go back to the video and understand. So then about the stage A quiz, some people are asking about the quiz and what tag along code is. Let me just say it. The information is already there on the platform, but tag along code is the code you use in answering some of the questions in the quiz. Because you can't answer some of the questions in the quiz without running code. The information is already there. It's already there. So that's the meaning of tag along code and quiz. So if you submitted just the quiz and not the tag along code, that will be detrimental to you. So both work hand in hand. So, and the instructions on how to do that, if you don't have a GitHub profile by now, create a GitHub profile, create a public repository, upload your notebook using Git or whatever format you like, and submit the link of your Jupyter notebook. And mind you, the notebook and your code should have attributes, input and outputs, and it should be an IPYNB notebook, not a Python script. It should be a notebook, either your Collab notebook or Jupyter notebook, but you must upload it in a GitHub repo, and your notebook must have inputs and outputs for it to be graded. That's for grading purposes. If you submit a Python script that's .py file, it won't be graded. If you submit something else, if you submitted just a link to your direct Collab notebook or your Jupyter notebook on your local host, there's no way you can access that. So you have to upload your notebook to your GitHub repo that is public. If it's private, you can't access it. You'll be graded 0 for that. So these are the instructions. Someone asking about where you view the results for tag along code. At the end of each stage, results will be shared. So that's not a problem. Always stick to the announcement channel. You get that. Okay, we've spent a lot of time, more than we bargained for. All right, thank you everyone for joining this session. Like I said previously, my name is Ajulo Christian, the Assistant Programs Manager and Data Scientist at Hamoye. Have a lovely day. Bye for now.